Good morning to the participants and to the presentators in this Triple Helix conference on innovation for sustainable development. It is quite a privilege to bring together the coordinators of several projects that are supported by the FAPESP, FAPEAN foundations. We would like, first of all, to thank the organizer from Triple Helix, from FEIA, and from the other institution, and acknowledge the relevance of the theme called Science and Technology to Enhance the World for the Future Generation. The project that will be introduced now, they are all aligned with this mission. So what we will do in the next hour is, first of all, to present the role and the contribution of this session. This session will apply the concept of a university and research institute as a dynamic open system engaged with society and its actors, and emphasize the importance of collaboration among institutions for sustainable development. It will assess how university and research institute can have a major impact, socioeconomic impact in the region that has a huge demand in educational and technological needs to preserve a critical global resource, which is the Amazon biome, and play an important mediating role between the local population, policy environment or environmental policy, and economy and the international scientific community. This will take us to the importance and the key elements for sustainable development in the Amazon region. Adalberto Val, who was the director of the National Institute for Amazonian Research, has always been underlining the importance of a strong scientific community in the region. And why this scientific community is important? For many key elements: to make available qualified professionals, to value traditional and local knowledge, to drive innovation and creation of sustainable employment, to improve the health and the well-being of the population, to influence and guide policy at the local and regional level, and finally, and not less important, to promote the robustness and openness of the scientific networks. And this is the key word for us, which is networks. Networks. Why networks are important? In a scientific network, the links formed represent the transfer of knowledge between its producer and users. It can be represented by co-authors' articles, article citation, article usage, or even mobility of researchers and students. A strong network has a few vital characteristics. First, interaction occurs repeatedly. Second, networks are resilient because if an individual withdraws from the network, without it will not cease the interconnection. The other links will continue interacting. Networks evolve over time, showing an interdependence that changes the nature of the work that members of the network can produce. Having said that, let's say now what FAPESP and FAPEAN are inducing. They are inducing several projects, around 20. We just selected 5 of them, one on value chains, the other one on juvenile matrinxã, the third one on phytotherapic chain, another one on bioactive composite, and finally the fifth one, recovery of altered areas. So these are projects that are bringing together scientific groups from Sao Paulo and from Amazonas state to work together. And what we did was to ask to each one of these projects, I would say 5 projects, but we are talking about 10 coordinators at least, each one representing the state of the Amazonas and the state of Sao Paulo. And the question that we have addressed for them to answer in not more than 10 minutes are the questions that are here. how the project was formed, how the researcher met, what is the nature of the project, how the theme was decided, and finally, and not less important, are the expected results and impacts. And so now I have the privilege to give the floor to my colleague in this project, and I want to thank all the members of this first project regarding value chain. Adalberto, the floor is yours for 10 minutes.
Thank you, Jacques. Are you listening me okay?
Very well.
Okay, great. Well, our project is designed to analyze the critical factors and to increase the competitiveness and sustainability of some value chains based on biodiversity in the state of the Amazon. Of course, all these products from biodiversity occurs all over the Amazon, but we are centered on state of the Amazon initially. And we consider also this product, especially those with high consumption potential in the state of São Paulo. The products that we select for the first approach is the fish pirarucu. For those that don't know, the pirarucu is the largest scaled fish in the Amazon. It grows up to 250 kilos. It's an air-breathing fish, grows up to 15 kilos over the first year of life. Then three forest products, açaí, cocoa, and Brazil nut. The basic idea is to identify the factors that inhibit or propel for high performance of these products and the solutions to the identified problems proposed. The program is designed to have three vertical approaches: value chain analysis, follow-up metrics and indicators, and human capacity building. And four horizontal points that are, as I mentioned, this cocoa, fisher, basically pirarucu, possibly tambaqui included here. That's another important fish in the Amazon, food fish in the Amazon. And then açaí, and then Brazil nut. Next, please. Just for a reflection on this, this is the geographical distribution of scientific production on these four products. I would like to pinpoint here that all these four products, including here the fishes, pirarucu, tambaqui, and matrinxã, are endemic to the Amazon. And no, for the Brazil nut, paradoxically, we have only a few papers published on these Brazil nuts internationally. Most of the papers are located in North America and Europe. If you take the fishes, it's the contrary. In fish, we have many papers from Brazilian institutions, but we have also, despite being endemic fish, lots of publication in the United States and Europe. I would like to call attention here for papers on these Amazonian fish in Asia. And I'd like to mention too that tambaqui is becoming one important export item from China nowadays. Next one. And another point that I would like to mention here is that the scientific needs for each of these products is distinct. And as I mentioned, the açaí, for example, is heavily researched in the Amazon, and the most important institution researching açaí in the Amazon is the Federal University of Pará. Next, please, Jacques. And as you can see here, the 10 institutions from Brazil that is researching açaí. First one is University of Pará, and then Embrapa, University of Campinas, that is located in the south part of Brazil, the southeast, University of São Paulo too, the UNESP, all 3 institutions from São Paulo, then the University of Rio de Janeiro State, Federal of Rio de Janeiro, and then another 2 institutions from the Amazon, the Rural Amazonia and University of Amapá. The expected results and impact of our project is to identify critical factors for the competitiveness and sustainability of these value chains based on the biodiversity of the Amazon, in particular of the state of the Amazon. We aim to identify the high performance inhibitors and drivers to produce solutions that responded to these identified problems, to systematize of experiments, associations, and cooperatives, aiming to reach innovative business practices and propose replicable frameworks on biodiversity or for biodiversity value chains. Then to propose metrics. I think that's very important for monitoring the governance of value chain components and to articulate producers and consumers. And then we want to make some recommendations, some public policy recommendation for job and income generation. Food security, that's a major issue for coming years, and citizenship education will be prioritized. The outcomes dissemination through website, books, articles, and digital contents and videos is another main goal of our program. I would like to invite you to visit the site of our program, our project, that's on the screen there, and you'll find some information on all these chain values of the Amazon. And I would like to thank you for your attention.
Thank you very much. Thank you very much, Adalberto. I think that you did a great presentation in less than 10 minutes. Congratulations. And I would like now to invite Professor Glaucia from Unicamp for her 10 minutes presentation. Yes, perfect.
Perfect.
Excellent. Let's go ahead.
All right. Our project is about chemical characterization of bioactive compounds from conventional food plants we call PANC, P-A-N-C, for development of products with functional appeals. São Paulo side from FAPESP is Dr. Iramaia Numa, Dr. Henrique Arruda, and the Amazon group from IFAM Institute is Professor Valdeli Knupp, Professor Jaqueline Bezerra, Professor Lúcia Boeira, Professor Pedro Félix Campelo, and Professor Edgar Sanches. And we are so happy because we can start this cooperation with this special group. How was the project formed? It's important to say that FAPESP and IFAM research groups aimed to fit at least 4 goals of ONU goals for the millennium, as no poverty, no hunger, good health, this is very important, and partners for the goals. The expertise of this partnership is in food science, in nutrition, biotechnology, chemistry of natural products, food technology, and food product innovation. So we can work together because there's different approach about this material, about these plants that we are studying. As we know, Brazil has 20% of the world biological diversity. And the Amazon forest, we have a lot of unexploited plant species. So we think it's very possible to get innovative products in several industrial fields. So from Amazon plant species, we can prepare new ingredients for the industry. And here we can think about the food industries, pharmaceutical industries, cosmetic, in any possibilities to use. And it's very important to study what is these compounds and how each function in the human body. Okay, so we improve the science and using research and development to obtain new products development. And the final goal is good health and well-being. The results that we are expected is about obtaining extracts rich in bioactive compounds using clean and renewable technologies, adding value to the product obtained and mitigating the environment impact, establishment of a database of Amazon punk of industrial interest, provides subsidies to economic exploration and industrial application of the punk in the food, cosmetical, and pharmaceutical fields. Development of new ingredients in processed foods from Brazilian biodiversity with functional properties. I want to say that all the world is worried about the importance of the functional properties of the food in order to keep the health, to prevent disease and aging. In this point of view, most of the Amazon fruits have a lot of bioactive compounds that will be very useful in this proposal. We expect the results, the impacts will be to generate scientific acknowledgement and technological development of high impact and with significant novelty and relevance, to involve the participation, training of qualified personnel. This is very important. Thank you very much.
Thank you very much, Professor Glaucia. I think we had not only an introduction to what you have been doing, but also you were kind enough and generous enough to send us most of the articles that are related directly to your project. And so what we can see is that the two groups that you have, one at Campinas and the other one in the Amazon, are already active. The project FAPESP-FAPE1, for the one that are following us by YouTube, by the Triple Helix conference, just began in March of this year, and we are in June. This is a at least 2-year project, and so we are just at the beginning, and what we are doing is sharing what FAPESP and FAPE1 are inducing in terms of networks from two very distant states the state of Sao Paulo in the southeast, and the state of the Amazonas in the north. Professor Mario and Professor Marciel, you have now your 10 minutes. Please, Professor Mario, go ahead, and I will move the slides.
Thank you, Professor Jacques. The title of this presentation is Restoration Treatment in Secondary Amazon Tropical Forests. The coordinator of this project is myself, Mario Tomasiello, from University of São Paulo, located in Luiz de Queiroz campus in Piracicaba, and the Professor Marciel José Ferreira from Federal University of Amazon. Next, please. So you can see in this slide a map with the statistics, the statistics of the natural forest regeneration areas in different forest regions of the world. But the main aspect is to evaluate the total area in Brazilian in order to compare with other forests, but also to give an idea about how many hectares have regrown in Brazil during the last 20 years. In total country, total area is almost 60 million hectares of forests. But concerning Amazon tropical forests, you have 20 million hectares of forest only in Amazon tropical forest during the last 20 years. So you can see some benefits of secondary forests, given high capacity to provide goods and service by silviculture management. And in the left side, the natural regenerative methodologies, you can see the possibility to increase the species by diversity, and also provide the ecosystem goods and service and support rural economies and livelihoods. So in the right side, during the last 50 years, there is a significant increase of species by biodiversity concerning the commercial dominant and non-commercial forests. Also, at the same time, a significant increase of stem volume, also considering the three classified type of forests. The scientific questions of this project, the first is, what are the effects of silviculture treatments on growth and wood quality of commercial tree species and Amazon secondary forests? And the major objective of this project is to investigate if silviculture treatment support the sustainable management of Amazon tropical secondary forests. Now I will continue the presentation by Professor Marciel, please.
Can you listen?
Yes, very well, Marciel.
Okay. Thanks, Professor Mario. I'm Marciel Ferreira, professor at Federal University of Amazonas, UFAM. Next, please. So this research will be realized in the Central Amazon secondary forest, located at the experimental site of UFAM, 38 kilometers north of Manaus, Brazil. We'll test 2 experiments for secondary forest management. Experiment 1, highlighting yellow color in the enrichment plant installed in 17 hectares of secondary forest with 19 years old. And the experiment 2, highlighting in red color, is a forest tree liberation treatment applied in 35 hectares of secondary forest with 35 years old. At the enrichment planting experiment, we have planted 1,800 seedlings of 6 commercial tree species: cedar, ipê amarelo, mahogany, jatobá, Brazil nut, and andiroba, that were subject to a gradient of light after different intensities of thinning on trees from natural regeneration. We have monitored the survival and growth of seedlings since 2007 year. At the forest tree liberation experiment, the secondary forest, as shown before, is dominated by cupiúba trees, one forest species with high economic value. However, this species grow under high competition with non-commercial tree species that may reduce the timber productive in this ecosystem. Thus, after forest inventory, we will apply thinning on the non-commercial trees and remove lianas competing with cupiúba trees. As shown in these figures below, these species exhibit distinct annual rings. Then, time series analysis will be made by cross-dating to characterize their radial group. From the tree ring rigidity, the annual diameter increment and cumulative diameter growth will be calculated to find long-term growth patterns of trees before and after thinning treatment by dendrochronology techniques. Finally, we hope that silvicultural treatments improve the growth and timber productive of Amazon commercial tree species, keeping the ecosystem services provided by secondary forest. Sustainable forest management for wood production on secondary forest means low pressure on the remnant tropical primary forest. And last, conservation of tropical secondary forest by appropriate silvicultural management may contribute significantly to climate change mitigation. This project is a collaboration between ESALQ, USP, and 3 institutions from Amazonas: Federal University of Amazonas, UFAM, National Institute of Amazon Research, INPA, and the University of Amazonas State, UEA. Thank you very much for your attention.
Thank you very much, Professor Marciel, and thank you very much, Professor Mario. Where are we standing now before giving the floor and the share space to Professor Sergio from UNESP? We began with value chains, Adalberto Val bringing us our concern with fishery and with 3 non-forestry products. We are talking about cacao, Brazil nuts, and acai. Then we went to chemical components with Professor Glaucia, Pastore from Unicamp. Then now we were able to see the potential contribution of what is called secondary forests, which is not only determined to improve the income of local communities, but also it's a contribution for Brazil to achieve the national determined contribution in the Brazil Accord, because we have to recuperate very many of our altered forestry that in many cases has been destroyed. So these are 3 contributions that were selected by FAPESP and FAPEAN to be financed for the next 2 years. And it is building on researchers and groups that already knew themselves. But now, through this induction, these networks are not only connecting, but they are creating synergy. And what we hope is through this opportunity to meet is to create a synergy also among these 5 projects. So now let me give the floor to Professor Sergio from UNESP. So he will continue in the fishery area, and then we will move to the last presentation from Unicamp. Professor Sergio, do you have your presentation? Do you want to share it with us?
Okay. My name is, good morning, everybody. My name is Sergio Ricardo Batlouni. I'm a researcher at the São Paulo State University, and I stay here in the Aquaculture Center in the city of Jaboticabal. I work with fish reproduction. And this project was made in collaboration with my colleague Professor Rafael Yutaka Kuradomi from the Federal University of Amazonas. And we also have participation of other researchers. The idea, the title of the project is Technological and Scientific Prospection as a strategic tool to intensify the production chains of juvenile matrinxã. Matrinxã is a rheophilic migratory fish. So, answering the question, how was each project formed and how did the researchers meet and agree to carry out research? So, we started this line of research a kind of 10 years ago when we tried to understand the reasons why some matrinxã females did not spawn even when they were hormonally induced. So part of the females did not spawn, and it's a very big problem for the production of this species because you lost all of the fingerlings you expected to have. So this was our first study in this line of research, and we observed that this type of problem, this dysfunction occurred in a series of other native species. So here we have some photographs showing these 10 years of collaborations. We showed our papers and abstracts in many meetings. In this upper photograph here, there is we are in Manaus in a meeting, and this one, Professor Neil Duncan, is one of our collaborators. We work together in a net called Larva Plus in Brazil about fish production. Here is the day of the Rafael doctoral thesis defense, and here we have many of our collaborators. And during these 10 years, we have explored this problem, this dysfunction in many native species used commercially. Answering the question, what is the nature of the project? How was the research theme decided upon? So I answered this question showing this photograph. When in the right photograph, we have a bag with the many fingerlings, and the final aim of our research is produce excellent quality fingerlings. So the fingerlings we produce from native fish can be used to aquaculture purpose or for fish restocking programs. That is the case here. In many rivers from the southwest region in Brazil, for instance, we do this kind of project, and fingerlings has to be of excellent quality. So breeders have to spawn, and the fingerlings have to have excellent quality. So this is our main purpose here. So in this line of the reproductive dysfunctions, we worked in these 10 years, Rafael and I, in making research with many species. In this line, in this upper line, are 3 publications with Pacu, that it's our main line of research, and we are using a new hormone. We improved the technique of hypophysation in Pacu using a new substance called prostaglandin. It's not a new substance, but it's a substance that had never been used to fish spawning. So we showed that we can improve Pacu spawning using prostaglandin. So we studied reproductive dysfunction in other species also, such as matrinxã, lambari, and also in a very interesting Amazonian fish species, the mapará. It's a planktivorous catfish with high potential for aquaculture. So we are trying, our line of research is to try to fix reproductive problems in species used for aquaculture. What are the expected results and impacts? How has the multi-state structure of the research project influenced, and how the project is being carried out, and what is expected impacts? So in this proposal, we are introducing a technique, in vitro cell culture, to try to understand more precisely the effects of hormones in ovarian cells. So we are changing in vivo studies to in vitro studies because it's more precise. And we have some answers that we cannot evaluate with in vivo models. So we will try to understand the effects of prostaglandins in vitro models. And for laviculture, we are trying to insert the biofloc technology to try to get better this step of the production of matrinxã also. Finally, we aim with this study to improve the fish production chain of matrinxã and other native species by improving two of the main steps in their initial phases of production, that is reproduction and larviculture. So it's our focus. I thank you. It's all.
Thank you very, very much, Sergio. Thank you for this excellent presentation too. I would give now the floor to Professor Rosana for the presentation of the last of the 5 projects. And I will leave for the last few minutes of our session one question. Why should we expand beyond the boundary of our institution to cooperate with other institutions? And what are the benefits of cooperating in networks instead of working only with internal groups in a specific research institute or university? But this is a question that I will leave for the last 5 minutes. And Professor Rosana, please feel free to take the floor.
Good morning, everyone. This is working, the presentation?
Yes, very well, thank you. Yes.
Okay. So it's a great pleasure to be here with you, our colleagues. Thanks to Professor Jacques Marcovitch for this invitation. That is a great opportunity to us to show you our research proposal and to share with you some concerns about the possibilities for Amazonian development in another key that is the key of sustainability. So this is a project about the Amazonian herbal medicines, in Portuguese, Phytotherapicus, chain integration, Profitus Bioem. Here we have our research team, and here in the center of this figure, we have these 2 ladies, which are Maria Beatriz Bonacelli, who is our coordinator from Unicamp, and Nadia Lepsch, who has done her postdoctoral research under the supervision of Professor Bonacelli at Unicamp. And this is how the story about this project starts, with a common interest on scientific production of knowledge on conservation and genetic conservation on Amazon region. And so a few years ago, this is the beginning. And here we have to the left, on the left, We have our research team from Unicamp. On the right side, you have above Jorge Porto, who is our coordinator from INPA. In our research team on the bottom, at the right, the research team from UFAM. So this is our synergies between our research competencies to endure this research inquiry. We have some competencies on well established, in fact, on institutional foresight, ISTI planning and management, natural products, ecology, genetic, chemistry, sociology, agroecology, traditional people and territories, and scientific competencies and knowledge production mapping. This is we have to put together to create synergies to face our main proposal, that is to contribute to promote a closer integration of the Amazonian biodiversity herbal medicines chain. That is an interdisciplinary, interinstitutional, multi-method research action project that encompasses 3 steps of methodology development, its application, and transfer. That is why I think it's a great opportunity to work as a network, because this provides us the real opportunity to put this expertise together. In order to do so, we have managed to organize the project in 5 fronts to put the competencies together in an interinstitutional and interdisciplinary focus on the research front. Those are front 1, prospecting stakeholders in the Amazonian herbal medicines chain with associated tasks. Front 2, benchmarking of herbal medicines in selected countries. Fronts 3 and 4, Amazonian medicinal plants prioritization method development and case study. And front 5, validation of the methodology and capacitation and transfer. Our originality is our methodology. It's a methodology for technical productive prospection and prioritization based on commitment building with legitimacy among the actors in the chain. This in order to help stakeholders and policymakers to define the Amazonian species and bioproducts to be studied, and to overcome bottlenecks and stakeholders' lack of integration in the chains. That is a great concern. Motivation and an expected impact is to meet SUS demands. This is our Brazilian public health system, much at this point these days. Meeting the Amazonian herbal medicines inclusion and production needs by SUS via Farmácia Viva project is expected impact. Which species are to be prioritized? This is the case for the prioritization methods, development, and application. Who is or who are going to produce such herbal medicines? This is a case for the technical productive prospection methodology, development, and implementation. Here we have the example of Oncaria tomentosa, cat's claw, unha de gato, which allow us to illustrate general features of herbal medicine's chains. It allows us to raise key questions that are at the center of our concern, such as the value that is added outside Amazon region within a fragmented chains, with difficulties in sharing benefits and problems on certification and regulation. Here we have some forms of presentations of Oncaria tomentosa, cat's claw. Several kinds of product presentation that begins with the product sold in bulk, unregulated, without any information in local markets. Two mode of presentations is the unregulated with the species name, date of manufacture and expiration date with indication and method of use, with a little more aggregated value. The third is regulated by other sectors, such as food and cosmetics, and so yet indicated for diseases. The fourth case is regulated manipulated herbal products with further value added. And finally, the regulated industrialized herbal medicines here at the bottom, with the presentation that you can buy at the drugstore, and the products that are made outside Amazon region. So who is behind this process of production? Where are they? How to add value, how to share value, how to aggregate knowledge from traditional knowledge, from certification, from regulation, so on. Key results of our research are contributed to a method for technological prospection and prioritization, to transfer these methods and to train stakeholders on the development method, provide human resources capacitation within our own institutions and stakeholders, and some expected impacts. We help to meet sustainable development goals and their targets as SDG 3, well-being, 12, consumption and production patterns, and 15, biodiversity, terrestrial ecosystems protection, to meet SUS demands and needs. Methodology appropriation by stakeholders, integration of actors in the herbal medicine chains, strengthening of the chain in the Amazon, decommodification of biodiversity, and strengthening of the ISTI systems, both in São Paulo and Amazon states. Thank you.
Thank you very, very much, Professor Rosana. I think this was an excellent conclusion for our hour that we are together. You brought together many common denominators that are present in the 5 presentations. Sustainability, employment generation, local development, competitiveness, connection between the state of the Amazonas and the state of Sao Paulo, scientific knowledge put at the service of the creation of new products and new services, and health as one of the targets that you just presented as the end project objective of your project. And looking at most of the members of our society, because when you mention the Farmácia Viva, this will be a way to achieve this universality of access. With this excellent presentation that we just had, in the last 3 minutes, I would like to answer one question. Why should we strengthen scientific networks? Why should we go beyond the boundary of our institution and cooperate with other institutions and with other networks. I think that there are 5 key words that we should remember at the end of this session, which is the beginning of a dialogue among the 5 projects and maybe other projects that are financed by FAPESP and FAPEA. The 3 key words are synergy, diversity of perspective, and visibility and impact. When we are working in network, there is a synergy of action because there is more knowledge that is produced and because there is less repetition and efforts and a greater shared learning, like the greater shared learning that we had in this morning. The second keyword is the greater diversity of perspective in the knowledge creation process. I think that what we were able to see today are how one project can inspire the other in what is being done and what should we deliver in terms of results and impact. And the third keyword is visibility and impact, because when we are working in network, higher visibility and impact for all the knowledge produced become a way of working together. And when and if we will have a paper published by several co-authors of several institutions, several regions from Brazil, definitively the potential of impact will become higher. And this is a contribution of our Matrix project that is also financed by FAPESP and helped us to prepare this presentation. Finally, and not less important, is that if we continue working together and if networks become stronger, this will provide more access to financial resources. Because we need today an infranational action, considering what is happening in Brazil at the federal level, we need more action and more traction at the infranational level. And if we are able to reveal how fruitful is this cooperation, very likely national resources and international resources can become available from multiple funding sources. So with these words, and we are already at 11 o'clock in Sao Paulo and 9 o'clock, 10 o'clock in Manaus, we will conclude this session. On behalf of all the project and the coordinator and the presenter, I would like to thank the opportunity of the organizer of the Triple Helix and FEIA USP and the other organizer for bringing us together. And thank you very much for this opportunity. Congratulations for the 5 projects and for the presentation that we were able to attend this morning.